Okay, thank you, Mr. Shalini. So I will first start by uh, share my screen. So you all see my screen?
Yes, we can see your screen. Thank you very much. Maybe you can just click on the presentation mode.
I would like to continue like that because
It's
I
okay,
wrote
yeah.
some note down.
Okay.
I first did it in French, and then I just translate the presentation. So there's some note that I don't write in my.
All right. So you have like
Explain.
12 to 15 minutes for a presentation.
Okay,
Thank you.
okay, good. So I'm Rollis Jiofack. I'm the HR focal point of it's a project of Water Youth Network. So now we will talk about fraud risk assessment, how artificial intelligence could be an issue for developing. We will first start by define what is fraud. So by the most, you can see by note down by the most basic definition, the fraud is the temporary submersion, natural or artificial, of space by water. So according to WMO, we have 8 kind of fraud, but we are interested in 3 main uh, fraud depending on our context, given that there are several risks of fraud linked to the melting of the slope. So we have, in our context, we have 3 kinds of flood: flash flood, due to the heavy precipitation, usually in mountain area with a high slope. We also have a fluvial flood, or also called it riverine flood. You all know that is due to the overflow of the major bed of a river. The last one is the urban flood, what we used to have in urban area like Douala or Gawande. And this flood is due to the waterproof and built area. So I will present you first what is we understood by flash flood. Flash flood is this type of flood. This is a video from Switzerland. So as you can see, flash flood is the most dangerous flood that we have, and it's due to the high slope and the heavy precipitation. We also have urban flood due to the urban area and the low infiltration. So the most water from the precipitation just there is something like 50, 55% of runoff from the water from the precipitation. So the last one is riverine flood. You all know what is riverine flood. So now we will talk about flood risk. What is flood risk? In this picture, we can see the flood, but there is really flood risk. This picture was taken in southern of Quebec in 2017. And as we can see on this picture, there is not really a flood risk. Because flood risk, if we talk about flood risk, there is an economical risk. On the next slide, you can see there, we can talk about flood. What is flood risk? Flood risk is defined as the expected loss caused by a given flood at a specific period, and it based on 3 elements. We will see the 3 elements on the next slide. So you can see there is an economical risk due to the submersion of the water on the space or on the land. On the next slide, you can see. So the flood risk and flood risk assessment. The risk of flood is assessed by the combination of hazard, vulnerability, and exposure. So in the hazard, by hazard, we intend the intensity of the flood and the speed of the water rise. The exposure is the exposure of the human activity to flood, and the vulnerability. In particular, vulnerability to flood is the predisposition of a community to suffer the harmful effect of the flood. It is reflected by the powerless or inability of the community to anticipate and to recover from the effect of the flood. So after the flood risk and the flood risk assessment, we can see how we can manage flood risk. So this is a picture made by the World Meteorological Organization and the Global Water Partnership on the joint program, associate program of flood management. So you can see the 5 steps of the flood risk management. The first step, reduce flood hazard, protect against flood, regulate land, raise awareness is like build an early warning system and also mitigate residual risk. So on the next slide, you will see an example of flood mapping. So you can see the water is a very short video where you can see the water in a urban area. So all what you are seeing is a building, it's a urban area. Is made in Ouagadougou. So we can do the same. Can do the same thing in Cameroon, in Douala or Yaoundé, urban area that we have in Cameroon. So we can do the same thing. I didn't do it because it took me too many times. So sorry if I didn't do it on Douala. But you can see the water level. Here is the water level on your right, and you can see the run of the exutoire. So after that, we will see how artificial intelligence will help us. When I was at WMO, I developed an algorithm to use artificial intelligence and satellite to prevent fraud and to map fraud, to help to map fraud for developing countries that we don't have that don't have measure. So we can use rainfall data from EUMETSAT. Rainfall data from EUMETSAT is given each 15 minutes. This data will help us to do a real-time forecasting. And we can also use, at the same time, the data from NOAA, RFA from NOAA. This data is given each day, each 24 hours. And we can also use a flood map that already made. So how the algorithm will run? We will use the RFA data for the last past day. We use those data to assess the Charles?
Yes.
Yeah. Please help me to translate it in French. I know in English, please. Donc, on utilise cette donnée, en fait, on utilise cette donnée pour évaluer le risque d'inondation tenant compte de l'antériorité. Oui.
Okay, so we use this data in order to anticipate, or we say to assess the flood risk by taking into consideration. J'ai pas suivi le dernier.
Tenant compte de l'antériorité, to consideration of the antériority of the flood. Yeah. Of the
So
event.
yeah, we use this data to assess risk float by taking into account the lesson learned and past. Let's say the past. Yeah, what's happened before.
Yeah, because we saw that the flood is not only made by the heavy precipitation, it's also made by the anteriority of the precipitation with the last precipitation that's happened before the present event that we have. So we study with that, with the RFA doing data from NOAA, the anteriority of the precipitation. So we use those data to build a kind of anticipation precipitation index. And we also use a flood map. So with the anticipation precipitation, with the RFA data, we can prevent the risk of flood of this day, of the day where we have. And we also use the MPA data to build a kind of real-time forecasting. So we use the MPA data to make a real-time forecasting at the day where we have, and we combine it to the RFA NOAA data to build a anticipation precipitation index. And if the index are the same with a flood of 10 years return period, we can just only show the map that already made. We have an example of map of flood map made by UNEP at the global assessment report. So we can either use those map or build another map with the return period. So the index made by the rainfall data will be combined with the return period of the flood. So we can only show a map of return period which is addressed to the index. So that is how the algorithm is working. We use all those trees data. This is the index, the precipitation of yesterday, the precipitation of before yesterday, and many other days. We can do it on all the season, in all the rainfall season, and give to each precipitation a kind of way that with the time, with the duration of that day and the day where we are making the assessment. Another issue could be to use the data of soil moisture from EMETSAT to assess the moisture of the soil, the risk of a rainfall in the area. So if the moisture is 100%, for example, we can build a risk of flood. We can build a risk of flood made by the runoff that we will have with this soil moisture of 100%. So with all those data, we can put all those data on a platform like that. So that is a platform made by the UNEP. We can access the flood risk. We can see the assessment of flood risk in Cameroon. So that's an example of how you can use artificial intelligence to assess flood risk. So thank you for your attention.